Greetings everyone, this is Non-Expert here back again with another video. Today we are going to be solving problem number 61 and the difficulty it's been rated at is medium. This problem was asked by Google and let's just dive right in. So you need to implement an integer exponentiation. Basically what it means is you need to implement a function called pow which takes in two parameters an x and a y which are basically integers and you need to return x raised to power y. So if there are no restrictions been given over here, this is a very simple problem. All you have to do is you just have to call a for loop from 0 to y and just multiply x with a value and just move forward from there. That is just considering positive cases and all that stuff. But over here, the restriction which has been given to you is that you need to do this faster than the naive method of repeated multiplication. So basically, you need to do this at a complexity which is better than O of n. And whenever somebody tells you this, whenever an interviewer tells you this, you can sort of think of this as a hint. And most likely the approach that you're going to be using is going to be something like a divide and conquer approach. And whatever algorithm that you're going to come up with is going to work at a complexity of log of n. And that's basically it. So you've been given an example over here, which is pow, and the two parameters which have been sent back is 2 and 10. So basically, you need to formulate the value of 2 raised to power 10, which should basically equate to 1024. So pretty simple, and fortunately, we are able to find a similar problem on LeetCode, and the name of the problem is pow x comma n. As usual, I would sort of urge you to pause this video and check out the link given in the description below and try solving this problem on your own. Over here, we've been given a few examples. I would actually suggest this for all people who are going to go for this interviews. The fact that, whenever a problem like this has been given to you, which is very, very easy, just don't take a paper and just start writing things down. You should take a minute, try understanding all the edge cases or all the test cases that you can formulate and then move on from there. So for us, the edge cases can actually be determined into three categories, or the use cases can be determined into three categories, which are sort of dependent on the parameters which have been passed to our function. So you have x comma n, and obviously, x can be positive and so can n. That's fine. X can also be negative, and n can also be negative. So x is negative does not really matter that much because if you have two negative numbers, if you're multiplying minus x with minus x, you're going to get x squared. So that's fine. But n being negative is something that you will have to consider, sort of have to handle a little differently. And whenever you have a value like this where n is negative, you could sort of just understand it in this way that the base that you presently are at is at the wrong place and you have to basically flip it out. So I'm not really too sure about the theorems, but in the most general sense, I can sort of explain like this. Like if you have x raised to power minus n, the way you can sort of, update this is basically like 1 divided by x raised to power n. And as you can see here, n will become positive, and that's just the way it sort of goes. So I'm not really too sure about the name of the theorem here. It's a pretty common thing. So if you have something like 1 raised to power minus 2, the way you sort of represent this is 1 divided by 1 raised to power 2. I hope that sort of makes sense. But we'll go on to the next use case. And the next use case is basically that, hey, if n has been given as 0, in this scenario, whenever n is given as 0, you know for a fact that whatever whatever x is at, that does not really matter. You always have to return 1. So whenever you have x raised to power 0, the value which you're going to be returning is going to be 1. So that's all the edge cases which we have computed so far. And now let's just talk a little bit about our approach. So let's just look at n for a minute, and let's just say that we've been given some value x. Let's just take x as x, and n has been given to you as 100. So the way to sort of break this problem down is that you can divide the value of n by 2. And as you sort of divide the problem by 2, the way you can sort of go about your computation is that you traverse through or sort of recurse through all the implementations of n till you hit 0, because you know for a fact that whenever you hit 0, the value which is going to be returned is going to be 1, and then you can sort of move forward from there. So basically, if we can represent this, you can sort of divide 100 to 50 plus 50, right? That's something that you can do. Um, So if you have x raised to the power 100, the way you can sort of denote it is as x raised to the power 50 multiplied by x raised to the power 50. So I'll just write that down over here just so that we're on the same page. Let's just write it as x raised to the power 100. So this can actually be represented as x raised to the power 50. And I'm just going to write multiplied by x raised to the power 50. Pretty simple, everybody knows this. And this is the way you want to break down your problem. So you have 100, then you can sort of compute 50, that's easier. Then you can compute 25, and then sort of move forward from there. So let's just go down a little bit more, and I'm just taking the first element over here just so that you sort of think about this. But this 50 will also have the same parts this guy's going to have. And now what you're doing is you're just representing as x raised to the power 25, and you're doing that 4 times. And over here, what you need to sort of have a look at is the fact that if you divide 25 by 2, you're going to get a value which is going to be 12.5. That being said, you can sort of think about this as an odd number. And the way to sort of compute this thing is very, very simple. All you have to do is you could sort of think of it as 1, 12, 12, or rather, let's not write 12, 12, we can just write it as 1, 24. And what I mean to say is that you can sort of represent this as x into x raised to power 24. So this is a very simple representation, but what it does is sort of breaks down the problem and sort of helps you out do more computation. So now what you're going to be doing is since you have x raised to power 24, you're going to be dividing it by 12. So you're going to have 12 over here, and then basically 6, and then so on and so forth. And that's basically the way to go about it. And you're going to go through all these solutions, and as you sort of go about it, eventually all those values are going to be returned to your function, and then you're going to use that function to equate the value accordingly. I hope that sort of makes sense. A lot of words, but it's okay if you do not understand. Let's just get to the code portion. Now over here, we're not going to go too much into the base conditions as such, but the only condition which I'm going to consider in the myPower function is the negative value of n. That's just because I'm going to make another utility function. I'm just going to call it as helper. And you can do it both ways. If you don't want a helper function, that's fine. But I feel like it's justified over here that the helper function just equates the value, and the myPower function sort of considers the negative n as well. So you can sort of think of this as a positive computation or positive power function or something like that, where it just considers all positive numbers. But that's on you. So let's just do that. Let's just say that, hey, if the value is less than 0, all we need to do is, and this is the same approach which I was telling you about, is just divide by self dot helper, and I'm just going to pass in x and n. Do note over here that I'm passing in n, whereas I need to be passing in minus n. And the reason why I'm passing in minus n is basically this helper function is going to consider only positive values as the parameters. Like x and n need to be positive at all times. So due to that, and with the exception of n being equal to 0. So with that keeping in mind, that's the way we're going to go about it. And if n is not a negative number, then we just simply call our helper function. Cool. So in the helper function, we're going to identify and sort of do all the divide and conquer approach. So it's pretty easy. We're going to start with the base condition, which is basically that, hey, if n is equal to 0, you need to return 1. Pretty self-justified. And the way I sort of explained the approach was that we're going to recursively call this helper function over and over again. We're going to store this value somewhere, and then we're going to utilize that value accordingly. So let's just call it as half, because we're dividing the value of n by half, and just call our helper function and just divide n by 2. And this half is just going to represent whatever value has been returned by our helper function, which we have just called. So basically, what if we have 100, if we have 100, we're going to get the value whatever 50 had, sent back to us when n was equal to 50. And that n, whenever n was, given as 50, when it sort of comes over here, it's going to compute or sort of understand or take whatever value was returned as 25. And that's basically the way to go about it. Now, all you need to do is you need to understand that, hey, is n the value which has been provided, which you're using, whether that value is actually an odd or an even value. And the reason for that is pretty simple, because whenever you have an odd value, the way you want to compute it is that you want to take the value x and then multiply it with the half representations that you built out. So let's just write that. Let's just say, hey, x into half is basically what we want when the value is odd. And when the value is not odd, the way you want to go about it is you just want to multiply half with half. Oops. Yep. So that's basically it. I hope this sort of makes sense. If not, we'll just put a few print statements. And actually, let me put a print statement over here. So you'll see the recursive calls, and you'll be able to basically you'll get a better idea of how it's working. So let's just run this code, and hopefully this should run fine, and it should return the proper output results as well. Awesome. So the way you can sort of see it is that, we start with the value of 10, and 10 is the value which has been sent to your helper, but the print is sort of working and showing us 1. And the reason for that is basically, that's the way the computations are going to go. So you're going to first compute what's the value at 1, what's the value at 2, and what's the value of 5, and what's the value at 10. The way you can sort of look at it is basically look at the last values and whatever they're returning. So if you sort of want to look at this, half is the value which has been returned. So 2 raised to power 5, or rather 2 raised to power 10 divided by 2 is going to be equal to 32. And that's just the way to, you're going to be going about it. So the values are going to get computed, they're going to be returned back to the recursive call which had called this function, and then it's going to move forward from there. And you can see that the result is the same result as the expected output. And let's just run this and submit this. Hopefully it should get submitted. And awesome, you can see that it's running faster than 39% of the Python online submissions. And that's actually pretty slow. So you might be asking, can we speed this up? And we actually can. It's pretty simple to do that. Let's just, make instantiate a memo function or a cache function, and then use that value or the cache value inside my helper function. And the reason why I'm going to do that is basically when you've computed, let's just say 25, and you compute the value of 50, you know that 25 is going to get called again. So when that happens, you don't really need to do the computations all over again. You can sort of save them and then move forward from there. So yeah, as I was talking about this, you have a self.memo, which is going to be global to the object. So we can sort of use this memo function and then move forward from there. So that's very, very simple to do. And I've sort of explained how, you cache or memorize or whatever you want to call it, your functions. It's very, very simple. And over here, what we're going to do is, since we have two parameters, x, comma, n, we're going to be leveraging those things, and we're going to be, saving those values inside our self.memo. So we're just going to say, hey, if x, comma, n is not in self.memo, then we perform all these operations, and eventually we return self.memo and pass in x, comma, n. So do note that in a dictionary you can pass in a tuple, and that can get hashed out. And I'm just going to copy this and replace all our return statements or whatever valid return statements we had, and just update them with this. So your return gets updated over here, and same thing over here. I can actually move out the if n is equal to 0 and it's returning 1. We can sort of move that out. The reason why I'm moving that out is basically that's just going to happen once, and it's just returning a simple value. So that's completely okay. So that's basically it. Let's just try running this one more time. And all I've done is I've just updated the values which you've computed, which you were returning rather, to your helper function, and push them inside self.memo, and then basically return to self.memo. If it already exists, this thing is going to get called automatically. And let's just go ahead and submit this. And awesome, you can see that the speed has increased a lot. Now it's faster than 92% of the Python online submissions. Memory usage is a little bad. That's only because you're using a self.memo just to cache whatever values that you have inside your helper function, so that you don't do the computation again. And that's basically it. So again, the way we have sort of gone about it is we've used a divide and conquer approach and just divide the value of n by 2 and just broken it down as two partitions every single time and then move forward from there. Cool. So if you have any comments or if there's something that you did not understand, do leave it in the comment section below. I would love to handle any of your queries. And if you did like this video, give a like and do subscribe to the channel. We are a discussion over here and we would love to have you on board with us. And if you've already subscribed, you're awesome. We all know it, and have an awesome day. Thank you.